Okay, let's sketch the region represented by the integral. So this time we're going to actually go backwards. So if I'm going to sketch the region, draw myself a set of axes. As I look at this, the outer integral is x, so this is going from x equals 0 to x equals 2. So I'm going to be going from x equals 0 to x equals 2. So the region I'm looking at needs to be trapped in there. The inner integrals are y, so I'm going to go from y equals x squared to y equals 2x. So y equals x squared at 0 is going to be 0, and at 2 that's going to be 4. So y equals x squared, we'll have that look. That's going to be the bottom. The item that's here on the y's will be the bottom, up to y equals 2x. And again, if I'm at 0, y equals 2x will be 0. If I'm at x equals 2, y equals 2x will be 4, and that's a line. And that'll be the top. So the region I'm looking at is that region right there. So again, notice what I did. I did the outer limits as the numbers, and I knew my graph had to be trapped in there. And then I did the bottom graph and the top graph in the case of the y's. Okay. Suppose I wanted to actually reverse that integration. Now that I have that, I could actually reverse the integration. So I could do f at xy dx dy. Now, the dy is the outer limits, so it's the bottom y to the top y. So the bottom y is 0, and the top y is 4. The inner limits are x limits. So I go left to right. The left graph is the line, so that's y equals 2x. But remember, I don't want y equals, I want x equals, so that's going to be x equals y over 2. So the left will be y over 2, and I could put equals x, but the y over 2 is what I need. And then the upper one, or the right one, was y equals x squared. Again, I have to solve that for x, so that would actually be x equals the square root of y. And I'm on the positive side, so it would be positive square root of y. And again, the items that contain the y are what I would keep, so I would actually be integrating from y over 2 to the square root of y.